Welcome to The Foundry. This explainer is made by Forge College, and I am absolutely thrilled to jump into today's topic: scoping execution integrations for analysis. So we're currently deep into our module on the comprehensive analysis of Sealevel execution, right? Which sits right inside our advanced Solana concepts track. Now think back for a second to our last lesson on debugging contention and advanced execution paths. We were really in the weeds there, weren't we? Well, today we're officially transitioning out of those messy, chaotic logs and stepping into the light to build a beautifully structured, highly defensible analysis plan. Let's get right into it.
We've all been there, right? You literally just survived debugging some brutal contention hotspots. Your eyes are barely adjusting to the light, and boom, a project manager drops this terrifyingly vague question on your desk. Hey, can you just make the execution more efficient? Sounds super simple, right? But seriously, how do we actually answer that without completely drowning in an endless sea of totally irrelevant runtime traces? How do you even prove you fixed the problem when the problem wasn't even clearly defined in the first place? Well, that is exactly what we're going to solve today. So here's our agenda for today. First, escaping the log jungle. Second, the investigation map. Third, questions to data workflow. Fourth, scoping a swap example. And fifth, preparing for data collection.
Section 1. Escaping the log jungle. Okay, so while our last lesson relied heavily on ad hoc debugging to uncover those hidden execution paths, today we actually need to completely shift our mindset. We're moving away from ad hoc debugging and embracing structured scoping. Now, ad hoc is fantastic for discovery. It's exactly how you figure out what's breaking. But structured scoping, that is how you build a repeatable, defensible analysis plan. Listen, if you don't define your boundaries right now, you're literally going to spend weeks chasing ghost traces that have absolutely zero impact on your final report.
Section 2. Building the investigation map.
To finally escape that noisy log jungle and actually scope our work effectively, we're going to adopt a brand new mental model. We call it the investigation map. It's kind of like a conceptual city map. Its entire job is to translate highly technical execution paths and runtime artifacts into an analysis plan that stakeholders can actually understand. We use this map to draw really strict boundaries, deciding exactly which execution integrations actually matter and which ones we can safely ignore. I mean, you wouldn't map every single tiny back alley if you were just trying to fix traffic on the main highway, right? Exactly. Same logic applies here. Just picture your system as a minimalist city diagram. Your programs and accounts, those are distinct districts. The roads connecting them are your cross-program invocations, or CPIs. And the traffic totally clogging up those roads, that's the contention and latency we need to monitor. When you frame it this way to a stakeholder, you aren't talking about low-level traces anymore. You tell them, hey, this main highway is causing 60% of our peak traffic. And boom, it instantly clicks for them. Section 3. Questions to data workflow. As we always emphasize in these Forge College learning programs, relying on a structured, repeatable workflow is absolutely everything. This 5-step process is literally the only reliable way to turn those vogue business goals into a precise plan. Step 1, you gather questions. Step 2, inventory integrations, basically list out the programs involved. Step 3, map those directly to specific artifacts. Step 4, define precise metrics. And Step 5, prioritize ruthlessly. So let's actually see how this plays out in practice. This translation table right here, this is the true engine of your scoping document. It perfectly links a super vague question like which CPI chain causes peak compute usage straight to a required artifact like a high priority per transaction CPI call graph. It explicitly defines the collection method like trace extraction from transaction logs, and it sets a firm priority. Honestly, without this table, you're just guessing at what data will make your boss happy. But with it, you've got a literal actionable checklist for success. Now, the absolute most crucial point is this: scope defensively. You have to write down exactly what you're excluding and exactly why. A great cartographer knows what to leave off the map. If a specific system-program interaction is basically impossible to instrument because, say, it's closed source, call that out explicitly. Document that it is totally out of scope right from day one. Doing this completely nips scope creep in the bud later on when somebody inevitably asks, hey, why didn't we measure this super obscure peripheral path? Section 4. Scoping a swap example. Okay, theory is great and all, but let's prove this framework actually works by scoping a real-world integration you totally see on Solana. Imagine a token exchange swap path.
A user initiates a trade, so the swap program triggers a CPI to an automated market maker, or AMM. Then, that AMM conditionally triggers a nested CPI over to an external price oracle. It's your classic swap to AMM to oracle chain. Now, during debugging, let's say you noticed this chain sometimes causes contention when oracle data gets stale. So how exactly do we scope this for the final report?
Well, first, we have to translate. Let's say the exchange operator runs into your office, totally panicking in business speak, are swaps hitting compute limits during peak periods? Now, we obviously can't measure panic, but we sure can measure operational reality. We look at the average compute units consumed by the swap CPI chain during the top 1% busiest minutes. See what we did there? That's a highly specific formula that we can actually measure using raw compute unit traces. We just turned a vague feeling into a totally solvable math problem.
Next up, we hit step 5 of our workflow, prioritization. You really have to prioritize your data collection ruthlessly here. High-priority items, like those main swap compute traces and Oracle lock timelines, demand heavy evidence. You might literally require at least 500 full compute traces for those main roads. But for the low-priority items, those peripheral system program interactions, the quiet, sleepy suburban neighborhoods of our map, we'll just settle for simple aggregate counts there. Please don't waste your bandwidth capturing massive full traces for low-impact events.
Section 5, preparing for data collection.
All right, so you are going to produce 3 beautifully structured deliverables to hand off. Number 1, your annotated investigation map. Number 2, the question to artifact mapping table we just walked through. And number 3, a sampling plan with really strict acceptance criteria. Together, these 3 artifacts form this rock-solid version-controlled contract between you, your stakeholders, and the evidence collection team. It clearly says, this is what we're doing, this is exactly why we're doing it, and here is exactly how we're going to measure it.
Which actually brings us to the absolute golden rule of scoping. High-impact, high-feasibility artifacts get full traces, but high-impact, low-feasibility items require explicit proxy evidence. Think about it. If an integration is super important but practically impossible to fully trace, like a closed-source off-chain oracle, you don't just throw your hands up and give up. No way. You explicitly document that you'll use proxy evidence, maybe something like higher-resolution transaction timing, just to fill that gap. Always keep this rule in the back of your mind when you're figuring out what data is realistically worth chasing down. And finally, as you prepare to hand off your scope document, always maintain a changelog of your scoping decisions and your assumptions. Why? Because the second you transition into actual data gathering, reality is going to hit you right in the face. You'll inevitably hit some weird, unexpected constraint. Maybe an archive node goes down or some log format completely changes overnight. If you've got a changelog, you can just easily revisit those assumptions and adjust your scope without having to start over from scratch. So, my fellow cartographers, are you ready to collect your traces and finalize your capstone analysis? We've laid the groundwork, we've defined our boundaries, and we've successfully mapped the roads. To dive deeper into this workflow and master even more advanced Web3 topics, definitely head over and visit forge.college. Get ready for our next lesson all about collecting and structuring evidence. But before I let you go, I want to leave you with this one provocative thought. If you don't actually define what success looks like before you start measuring, how are you ever going to know when you've actually found the bottleneck? Or are you just happily lost in the noise? Really think about that. Thanks so much for watching this explainer, and I will catch you in the next one.